Algebra 1 students, welcome to your 4.1 notes. I hope that as you get started on this, that you'll be open-minded to something that's a little bit different, but I think something that's fair. It's not that horribly challenging, necessarily, just something a little different. So, here's what I'm going to ask you to do. Right off the bat, we're going to sketch a graph that represents the story, label all axes. I actually want you to pause the video. So pause the video right now. Read the story. Once you've finished reading it, then hit play again. Okay, welcome back. Hopefully you've read that story. You kind of understand the situation. What we're talking about here is a situation. We're driving to Grandma's house. We're going to put time as the x-axis and distance is the y-axis. Now, since I can't turn my paper like you guys can, I'm just going to turn my words. There we go. There's distance. All right. Now, the way this works is we're essentially saying that distance of 0, or when we're on the axis, is when we're at home. That would be like right here. That would be home. And then somewhere up here is where Grandma's house is, that far away. We don't know the distance, and as a matter of fact, we're not really concerned about the distance for the context of this problem. What we want to do, though, is analyze what the graph would look like. So we'll start with this. You travel at a constant speed for 10 minutes. I'm going to put it like that and just say that that represents 10 minutes. Then all of a sudden we realize, oh crud, we forgot the pie that we begged to eat with Grandma, so we're going to go back home and get it. Now, as soon as we get the pie, we run in quickly, grab it, and get back on the road. We've wasted 20 minutes, and so it says then we need to drive. So we start at a constant speed. I'd assume we're driving at the same speed as before or something close to it. After 45 minutes, and so perhaps I should extend this just a bit. I'm going to run out of space if I extend it too much though, so we'll stop there. After 45 minutes, we are hungry. We have a pie in our car, but we choose to stop and eat at Wendy's. I have no words for that. I don't understand. Okay, so we continue. After 15 minutes, we're driving again, driving. Oh, traffic light slows us down for just a minute, and then we start moving again until we reach Grandma's. So our pathway would look something like that, and here's Grandma waiting for us, so excited to see us so she can give us 50 cents and eat pie with us. All right, let's take a look at the next one. Tell the story of the return trip back from Grandma's house. That would represent the graph. Now, I've actually got a story already ready. This is a beautiful story, one that makes me a little sad, but you can follow along with me. After eating pie with Grandma, I left her house. Okay, so the leaving her house and driving at a constant rate for 30 minutes is this part of the graph, right here. I then was stuck at a light for 3 minutes. That's this little portion right here. Before I started moving again, after 10 more minutes, okay, so here we're moving for 10 more minutes. After 10 more minutes, I stopped, that's right here, because I saw a dead animal. It's an emotional moment for me, I'm sorry, but when I saw that dead animal, I had to stop and see if it was alive. If I would have been paying attention, I would have known it was dead. But anyway, I stopped, and the rest of the trip was a tough one for me, and that's because I realized that the animal was dead, and I was sad. And I was also hungry, so I didn't bring the raccoon home, or maybe I did. But in any case, I drove slowly. That's why the slope is a little less steep than the rest of it. I don't know if I can continue faking emotion. So let's take a look at the next question. Okay, so on this particular problem, we have a model rocket that's taking off. Again, we're going to do time compared to distance. We're going to try to track the pathway of this rocket. It says it rises quickly as it takes off. It slows to a stop as the fuel burns out. Now, most likely, this is not going to be a straight line situation. This is going to be a parabola, so that there's going to be a curve right there. And immediately falls quickly until the parachute opens. So we're falling quickly, but then the parachute opens, and so it's still going to fall, but at a much slower rate. the parachute hopefully will slow the fall down so we don't break our model rocket. Okay, and actually I wrote distance here. As I think about this more, the better term to use would be height. It is a distance, but let's use height. Why not? All right, so the pathway should look something like that. These notes are fairly quick today, but we have one more that's kind of an interesting question. Look at the table. Determine which graph represents the average temperature for the 4 locations around the world. Now my eyes are immediately drawn to the graph. I see 3 of the 4 start low, move up, and then back down to varying degrees. One of them, though, starts high, goes low, and then back up. I'm immediately thinking there might be something in the southern hemisphere. If you think about geography a bit, which one's starting high and goes low, then back up? Well, that's Paraguay. Asuncion. Excuse my lame attempt at Spanish there. All right, so we know that's Asuncion, Paraguay. Now we've got 3 other cities, Olathe, Barrow, Alaska, and Honolulu, Hawaii. 3 of the best resort towns in the world, of course. Now, what we can see when we look at Olathe is that it starts fairly low, 26. It moves as high as 78. That's average temperatures, by the way, not average high temperatures. And then down to 30. Okay, so let's then look and see. Well, it's kind of hard to tell just based on this information. We can be pretty sure that this graph down here is not the correct answer for Olathe because we don't have this moving down then back up situation. But it's hard to distinguish these two for sure until you look at Honolulu and you see how consistent the temperatures are. The Honolulu graph is going to be the flattest one. This is where you have very consistent weather all year. Olathe does not have consistent weather. Barrow, Alaska, of course, doesn't either, and that's the one that starts at -13, then down to -18, then back up just a little bit to -15, and then it continues all the way to a sweltering 39 degrees in July. All right, folks, this is an interesting lesson. I hope you are able to do things well. I think it's actually a really good one, a little data analysis. It's a great life skill to be able to use. So, come to class, ready to work. You guys have a spectacular day.